As judges, why worry? Why so much people are worrying about the phase distortions? Phase distortions, which are for many people not noticeable. For many people, they neglect it even. What is the fuse? I don't want to show you some virtual presentations about phase and about mathematic formula. I want to show you something which is something you cannot find in other places. Some not usual approach to show the phase distortions, that you can see and you can feel this thing by yourself, by your ears. So I think this would be the proof of what is the problem and how much is the problem is affecting the quality of our listening, of our using of equipment. First thing, I would like to state some questions which maybe nobody is asking in normal way. We are using headphones and we are using speaker systems. Obviously, 99% of speaker systems which we see in market now, it is a multi-way system. There may be 2, 3, 4 or more ways, and for each channel, of course, is separate speaker assembled in a system. Headphones. Can anybody see? Did you see the headphones which have 2 or 3 bands? I don't think so. Why? It should be better quality. If it's in speaker better quality, then why it shouldn't be better in headphones? Well, this is a good question, I think. So maybe just imagine the power is the problem. For headphones, usually the power is of headphones is less than 50 milliwatts per channel, maybe some stronger, maybe 100 milliwatts. It is 1/10 of watt. And the speakers have, obviously, now it is almost no limit. So I need to stop my machinery here. Okay. And for a small headphone, it is not a problem to make a speaker adequate power which can handle even the full band of frequencies. As you know, most headphones are claimed to play frequencies 20 to 20 kilohertz. For speakers, it is not like that, because the speaker which has more than 5 watts, the dimension, mechanical and geometrical dimension of the membrane is starting to grow too much. And with this, we have the dimension starts to affect the geometry of listening. It means some parts of membrane are sending the signal from other point, which is more or less distant from us, and other part of membrane is sending signal in different distance. It means they are not coherent by phase. What is happening when there is no coherence? When there is no coherence, then for some frequencies which will be adequate to this difference of distance, for these frequencies we start to have more or less diminishing of level. So the solution which was found to keep the size of membranes in acceptable, let's say, range was to use few membranes which are smaller. Especially this is important for these frequencies which are affected by the difference. This is more important for high frequencies, for middle frequencies. For low frequencies, due to length of the wave, which is more than 20-30 centimeters, then the small differences, few centimeters, may be not very noticeable. So we need to do this mostly because of middle frequencies and high frequencies. Other, of course, point of this is that the bigger membrane is not capable to radiate flat characteristic, frequency characteristic. This is more or less also affecting the sound, and it is a very easy way and very useful way to make it in different ranges for different speakers. Then what is the problem? Next problem, because problem creates problems, as you know. For low frequencies, the speaker has a big coil, strong coil, and there is no problem with the power. For mid-range, it's already starting a little bit trouble, because mid-range is smaller, cannot have very heavy system of this vibrating system, and for this too much power for mid-range may cause it to damage by heat. The worst problem is, of course, for high toner, for tweeter. Tweeter is must be very light, very delicate, because it's vibrating with very high frequencies. So to keep the frequency in linear, we need to keep this very small and very teeny. The wire of tweeters is very teeny. Of course, there are different tweeters like electrostatic and some other, but all of them have the same problem. The power which they can consume by itself is very limited. We need to avoid to reach too much power in full range power. We need to avoid it to deliver to high to tweeter and to middle toner as well. For this, we try to separate whole band for 3 or more or 2 ranges. Each range is dedicated only for this speaker which is playing. And here is created a problem of phases. To cut the frequency range for this few parts, we need usually, it is the cheapest and the simplest way is to use filters. It is LC filters, inductive capacity filters, which are having their resonance frequency, and this resonance frequency is very nicely can be matched with a limit of operation for the speaker. Then, after that, when we listen, all speakers deliver their job to our ears. But is it, let's say, possible to add these signals in a not touched way so that it remains similar or the same like before cutting it? It seems that for filters known, generally used, it is not possible, because these filters accept more than cutting the frequencies. They make another change for frequency. It is just like twins. Frequency is equipped with a change of phase of the signal. This change of phase is for lower limit, opposite than the for higher limit. This is for all speakers. If the change is going in opposite directions when coming to the point of common frequency, then it's very bad. What we are doing, we are trying to make this change of phase the same polarity. It means if one goes down and other goes up, then we change the speaker polarity in our system. The phase of the signal will be reverted, and when it's reverted, then it will be matching more or less the upper limit of previous band. What we are getting bad, it's not cheap. We are getting that the main band of the speaker, two speakers, is in opposite polarity, because we are getting matching in it is called crossover frequency, but we are getting opposite phase in main bands. So the sound is usually not looking and not sounding very much like before the operation. I want to show you this on an example. You can hear it and you can see it, how it works. I don't have actually typical speaker column which could be presented here. So I use the sound and the speaker which is provided in this keyboard. This is a powerful keyboard from Casio MZ2000, and it's the speciality of this keyboard is very good acoustic system for the speakers. As you can see, I want to show you this maybe better this way. As you can see, the enclosure is big in the cross, and inside you have on both channels you have two completely separate systems for bass reflex and high quality tweeter. Also the speaker for this is 15 watts per channel, and I may just, you must trust me, because possibly you will not see it. This is the sound of this keyboard is really impressive. But what I'm going to do, I want to show you how is the face of this speakers, which is a product of Casio, and it's not touched. It is just by factory. The speakers are connected in two ways: higher tweeter and low toner, and the way of separation is just simple capacity connected in serial with a tweeter. This is highly acclaimed by audio world, because it makes the changes of phase rather slow, and some people say it's not very noticeable. Really, is it? We will see. Oops. I just took the microphone out, and and I need to go to this. What we see here? We see here no any effects, no any change of sound. I prefer to present the phase changes, noise. There is no noise in this keyboard, but it's very good sound, which is more or less similar to noise, and it's rain. Rain. Okay, we have rain. So I press rain. Okay, you don't see what I'm doing here. Okay, make it like this. Better. I hope better. Okay. So this is the speaker which is active. This speaker I just put by balance to out that it is not affecting our presentation. Yeah, it is. So rain. And now I am directly turned to the low toner. Now I go to high toner. Now I'm on high toner. What we can observe here? Generally, the sound is not very different in bands, because this is the common sound which is radiated by low toner and high and tweeter, and it's supposed to be just flowing this the sound from low toner to high toner without special changes. But what we see here, yeah, this is like zero. This frequency is lost, simply lost. The tweeter is radiating this frequency, the low toner is radiating this frequency. Together, no. They are in bad directions. They are not summarized. There is no sum of the signals. It is vector operation, which is giving result completely not similar like supposed to be. Of course, for headphones we have no like this situation. So for headphones, it is advantage of headphones. Headphone can handle everything and will not provide this lack of sound.